Arda.
Thank you. So, my name is Arda. I'm a part-time student. This is my 6th year in ITLS. My supervisors are Jyoti Bhattacharya and Rico Markert. And today I'll be talking about my latest work around large language models in supply chain management, which I've been working on for the last couple of months. The objective of my study is to look at how large language models can be used in supply chain management, and also using an intervention-based approach, how this could be related to a case company. I named it as the eyewear company. It was my previous place that I used to work for 2 years. Here I used ChatGPT along with several Python packages. One of them is LangChain. So I tried to build up a chatbot using available tools on Python and ChatGPT. So what we try to do is to come up with a methodology that will solve the problem that that company was having in terms of onboarding new supply chain employees, and in terms of training the current supply chain employees that they have using a chatbot, and training their own files. So the originality is that there are not so many studies using large language models for supply chain purposes, and there are a few actionable items that I'd like to talk about in coming slides. So first, I'd like to talk a little bit about large language models, what they are. They are actually advanced artificial intelligence models, and with the recent advances in deep learning, they became very popular, and they are models to understand human languages. They are trained on large text data with either self-supervised or semi-supervised learning. So basically, you need to give a labeled data. They are trained on large data sets, and that's how they understand us, and that's how they generate text based on that. They can learn language patterns and perform tasks based on the prompts. So the prompts are important, and they can generate creative content such as stories, poems, and even computer code. They have general knowledge, so they're not specifically trained, and they can memorize facts. They are expensive to train, but the costs are decreasing, and it's also a sub-area of natural language processing, which I've been working on different aspects of it since I started my PhD. Then ChatGPT is one of the platforms that we can employ. We can use large language models. It was presented in 2022 by OpenAI. It's an artificial intelligence chatbot. It is using the GPT architecture, which stands for generative pre-trained text. So basically, it can generate text, and it generates human-like text, although it has several limitations and concerns. One of the concerns is that it can fabricate incorrect results, and it can give biased information. So those are concerns, and some limitations are it has contextual understanding, and it has lack of emotional intelligence. It has various applications. So it is said to be passing the US medical licensing exam with 60% accuracy. So it's not bad, but of course not 100%. And there are lots of popular use cases of ChatGPT, but for our purposes, it's more like statistical analysis, code generation, and text summaries that we can use. Again, there are some challenges about its originality limitations and its contextual accuracy. What are some applications of large language models in supply chain management? They can have several applications, but related to supply chain management, they can be used for demand prediction. price forecasting and inventory optimization. There are studies over the last 2 years that are focusing on how they can be used in supply chain management, but these are mainly the areas: demand prediction, price forecasting, and inventory optimization. They are good in knowledge management, knowledge creation, data analysis, and automation. So now I'm moving on to what we have done. So the research methodology that we use is intervention-based research. So basically, there is a problem situation, which is called S, a real-world situation. In my case, it was the eyewear company's employee training problem. So the aim of the methodology, the strategy, is to bring the problem situation from S to S prime, so to a better place, using a theoretical framework, T. And that theory behind the study is the organizational learning theory. So what are the elements of the intervention-based research? The first one is the problem situation. So the problem was that there were challenges in training new supply chain staff at Eyewear Co. And it was a little bit complex because they had a global operation, so people from different parts of the world, and they need to be trained on same or similar materials most of the time. That's one of the complex areas. The other one was logistics and the compliance standards. There were also other HR concerns about employment laws, cultural differences, and recruiting, to name a few. Being conscious of time, I'm passing a little bit quickly, but if you have any questions, I can go back to the problems also. Next is the theory part. So basically, organizational learning theory came across to be the theory for our study because it has a cyclic approach around knowledge. So the approach starts from knowledge creation, followed by knowledge retention and knowledge transfer. And in terms of this training process, it's important to look at the steps of the organizational learning theory in terms of knowledge creation, retention, and transfer, and that's why relevant to the problem at hand. Next, the methodology, the strategy, how we can solve this problem of training new employees. We employed a large language-based model. So on the bottom left side, basically how the process starts with the PDF files of the training material. So there is a Python library called LangChain, which can convert PDF files into chunk of text documents. And with the word embeddings within the library, it can be stored as vectors. So text can be stored as, it can be converted into vectors. So like numbers that we can work with. So the good thing about LangChain is that it's not using the standard ChatGPT, but we're training the chatbot based on the documents that we provide to the system. So those PDFs are converted into text, a chunk of text. Those chunk of text, with the help of word embeddings, converted to vectors, and they are stored in a vector database store called FACE. There are several different others, but for this one we use FACE, which is a vector database for by Facebook. Next, the top right corner. So basically, when a new employee comes and asks a question, again, LangChain comes into that part and it understands the question with the help of question embedding. So it understands what the user is talking about. Then LangChain does a semantic search and searches the database, the vector database, the vector store. Based on that, it gets the ranked results. And again, use of large language models, it will give the answer. So that's kind of how the methodology worked. Some queries and answers. So I just put 3 of them. So for example, if we wrote summarize dispensing procedure, the answer is based on the documents that we provided. So it's basically the company's own documents. I converted them to XXX when it was a specific company name. So it can generate answers based on specific queries. Now coming into results, of course, before this, there were lots of PDF documents or different materials available to the employees. And they used to be searching them one after the other. And this was not an efficient process. But with this methodology, the users can go into the system and they can ask whatever they want to ask, and they can get results within seconds. So this created improved efficiency and accuracy. So basically they could get the answers to their questions much easily and more accurately. So there was significant reduction in time. And this process was done in iterative moments. So it just didn't happen at one go, but we did some iterations. So it was continuously improved over time. New materials are added. The old materials were updated. So it was better suited for the training purposes. So it kind of gave a tailored learning pathway to the new employees. And of course, it helped faster knowledge acquisition. Some challenges were the accuracy, privacy, and security. So we tried to address those again by tweaking the algorithm based on the specific questions that were coming. So yes, the accuracy concerns. We also held a training with the team about how to give good prompts, because large language model results are good if you ask the right questions, if you ask the right prompts. So we gave a prompt engineering training, and we gave an education on how to write effective prompts. And regarding on data privacy and security, we work with the ICT team of the company so that this data will only be generated in specific applications that could only be used by the personnel in the company, so that we could also eliminate the ethical considerations as well. So some implications for research. So this study is showing that large language models can be used in just one part of supply chain management, but it could be used in other areas of supply chain as well. One good thing about large language models is that it gives the ability to scale up, and you can adapt accordingly. As long as you feed new information to that, it can adapt in seconds, basically. And we also tried to make use of the organizational learning theory because this enabled knowledge creation for the company, and it enabled knowledge retention much better than the previous methods that they had. For practice, again, similar. I mean, not just for research, but large language models can be used for supply chain management, and the focus areas need to be on knowledge management, data analysis, and automation mostly. And it could be used to streamline operations. For example, any kind of process automation can be done with large language models more easily than the older traditional systems, so to say. So basically, again, I'll reiterate the same things. Large language models can be used in supply chain, and I think it will be used more frequently in the future. It has potential applications in various areas. I just touched on the training part, but it could be also used in demand prediction, inventory optimization. And the future focus will be more on the refinement of large language models specific to the data set that it's trained on. So the contextual understanding could be enhanced. That's the end of my presentation.